This is our Unit 7 test review packet. I'll walk through this fairly quickly just because it is review, but I didn't want to get the video out just so you had it. Question 1 right away. The first couple questions, we're just going to graph a parametric equation. And in this first one, we're given the parameter for x and the parameter for y. And in our case, we usually, when we're asked to graph and write a table, we try and use 0 as kind of our base for our time. So what I mean by that is we'll put 0 in the middle, and then we'll go up from there and down from there, like that. So then those are just arbitrary times we pick, or values for t that we're going to pick. So then all you do is you plug in -3 into the x equation, and you get -3 times 3 is -9 minus 12, that's -21. So that goes in for the x. The y value when t is equal to -3 is 6 plus 3, or 9. And we just continue that. So 3 times -2 minus 12 is minus 18. And then you plug it into y and you get 7. And these you get. So now that we have our data plotted in our table, we're going to go ahead and put that into our chart and in terms of our x and our y. So maybe some easy points would be like our -3 is a pretty easy one here. -6, -1 is a good one. -9, 1 is another one. And what you're going to find is this is a straight line, so we're going to kind of extend that best we can, and we'll draw our arrows. So that's all you do to get your problem like number 1 finished up. So number 2, same thing, but this is different because we're only graphing when t is going from 2 to 6. And when we have an interval, we just graph that extent of our interval. The graph may be an entire parabola, but from 2 to 6 on the interval t, we don't see the whole parabola, we get a portion of it. So in that case, we might create another table like that, t, x, and y, where t goes from 2, 4, 5, and 6. Another way we can do this actually is just simply graph it in our graphing calculator. Running these numbers, 2 for the x, that's 0, and then the square root of 1, square root of 2, square root of 3, and square root of 4, which simplifies to 1, 2, and then those square root of 2. There. All right, and then our y values are just simply 4, 5, 6, 7, and 8. So this one here, what it actually looks like, so 0, 4, we get 2, 2, 8. And again, if I would actually go ahead and put this into a graphing calculator to see what it would look like. But what you would find is it would look like this. Oops, my very first point is 0, 4, and my last point is 2, 8. So I would only graph that segment of the graph. If I put t greater than 6, so t goes up to 10, this would keep going. But since we don't go past 6, we just stop our graph. Also, because of this, we put arrows in the direction of our curve. And because we started at 0, 4, and we would have gone to 1, 5, see, there's another point there. That is the direction of our curve. So you have to make sure not only do you stop your graph in the interval that is specified, but you also point arrows in the direction for which the graph is constructed. All right, moving along. Question 3. write each pair in rectangular form. So in this case, also make sure you restrict the domain if necessary. We'll get to that here in a second. So I would say I'm going to solve the x equation. Anytime I can solve the x equation for t is easier, because in the end I have to have y equals something in terms of x. So it's easiest to solve the x equation and leave my y equation with a y equals by itself. So I'm going to go ahead and do that here. X is equal to 5t minus 2 is what we start with. So I'm going to add 2 to both sides. And then I'm going to divide by 5 on both sides. Oh, got ahead of myself there. So x plus 2 over 5 equals t. Now we can substitute that in and say y is equal to t squared. Well, t we know is our x plus 5 squared plus 1. At this point, that is enough. There's no simplification needed. I would literally just leave it exactly like that. Y equals that form of x plus 2 over 5 squared plus 1. Then you want to go ahead and graph. And when we graph this, the parametric equation does get graphed first, and then we would check it against the regular function, the y equals graph. Make sure that they have the same domain, essentially. There's two ways to do it. You can do it on Desmos, which is probably the easiest to do here before a test, but during a test, you would only have your graphing calculator. So what you would do is graph just the parametric. So let's do that here. Right there. So here's, make sure you're in the right mode. You go to parametric mode, and here's my x1, here's my y1. For this one, I set up a basic window. So max is -10 to 10, and our x min max, same thing, y min max, all -10 to 10s. My t-step is 0.1. Just to start. So if I graph that, I'm going to get something like this. And so I'm going to attempt to draw that. And what we actually find is, let's see, -2, 1. This does happen to kind of be the vertex of this, but it's going to be a very, very shallow bowl like that. If we go back, change our mode to function, we graph this. So that was x plus 2 over 5, and then plus 1. And we graph that. Oh, knew I forgot something. We have to insert that squared command. So x plus 2, oh no, let me clear this out. I have to do 2 parentheses. Then we've got x plus 2 over 5. That whole quantity is squared. There we go. Gotta make sure our notation's right, parentheses are right. Plus 1, throw that in, and we get the same exact graph. So that's just a way of confirming that we've got the right graph, and we don't need to restrict our domain. In our next graph, we're going to say we'll solve the x. So x equals square root t plus 1, x squared is t plus 1, x squared minus 1 equals t. Then we solve for y. We say y is equal to just t minus 3. Well, t was x squared minus 1 minus 3. So y is x squared minus 4. Well, if I go to my graphing calculator and look at it in the parametric, it would look like this. Got the equations if I'm going to keep the same window, I graph it. And all right, so that's what it looks like. Notice one thing, it stops right here at the top here. That is not because the graph itself stops. That's because I stopped evaluating t. So I'm just going to hit enter. I'm going to make my t max be like 25. And what you'll see is the graph will continue at least out of my window. So from there I'm seeing, so 1, 2, 3, 4. Down 4 is the bottom over 2. So I'm going to draw that. Let's see, down 4 over 2. So we got this kind of half a parabola going on. Now, just not even using the graphing calculator, y equals x squared minus 4. That's going to go down here, but that's going to give me an entire parabola. I don't want this half. So I need to say y equals x squared minus 4, comma, I'm going to restrict my domain so that x is greater than or equal to 0. Because at 0, it still works, and everything to the right works, but anything less than 0 doesn't, because then I would have extra graphing. So that right there with restriction is the right answer. So that is the first 4 problems on here, and that will do us for this video.